Okay, so as of right now, we know the geometric series test, the nth term test, the telescoping series test, the harmonic series, the direct comparison, the limit comparison, the integral test, the p-series test, and I think I forgot one, but we're moving on. This next one's called the alternating series test, and this one is for a series that's constantly alternating. So for example, what if we have this? It's going to be -1, and it's going to be 0 because you're adding -1 times 1, or plus 1 to be 0, -1, 0, -1, 0, -1, 0, alternating. That's what an alternating series is. So what we're going to do with this is we're going to have a two-step formula to be able to determine whether or not a series converges or diverges. Now I'm going to go ahead and do one a little bit harder than this, I think. I'm trying to see if I want to go to... Well, I guess we could do that. Let's say we wanted to do this series right here. -1 to the n plus 1 over n. Okay, so this is going to, let's think about this. The first one's going to be positive because you're taking n plus 1 is 2, -1 squared is 1. So it'll be 1 over 1. And then -1, 2. 1/3, minus 1/4. As you see, they're alternating, negative, positive, negative, positive. And that's going to cause a problem with what we're doing, because if you think about it, that's kind of like going here, and then here, and then here, and then here, and then here. Where are they going to converge to? And we'll be talking about that in a minute, how to approximate what this is converging to. But basically, the test for convergence is a two-step process. One, you're going to take first the square root of the, or not the square, oh my gosh. You're going to first start off by taking, I think the reason my videos are like this sometimes is because I always take these really late at night. It's like 9:30 right now, and I should be going to sleep. But anyway, you're going to take the absolute value of these functions. So right here, take the absolute value. And think of it like this. If the absolute value of this, any negative ones to the n's would just be positive ones. So therefore, this equals 1 to the n. Now that we have that, we need to, the two-step process is to check an alternating series. The first one is to take the limit of the absolute value. So in this case, it would be the limit as n approaches infinity of 1 over n. And just check to make sure that equals 0. If that equals 0, then you passed one of the tests. If that does not equal 0, then this is not going to converge. 2. We need to see that this function right here, the absolute value of the series, is non-increasing. So basically what you're going to do is you're going to first define this as a function, which we're going to call f of x, and say f of x equals 1 over x. We want to make sure it's not increasing, so what are we going to do? We're going to take the derivative of this. And the derivative of 1 over x is going to be, by doing, that was a 1, by doing some rules, you get -1 over x. As you're adding values to this, this is just going to get smaller and smaller. It's going to start off as -1, then -1/2, and then -1/3. As you see, it's getting not smaller. Okay. I guess, wait, did I say, oh, it's supposed to be like that. It's always going to be negative for x is greater than or equal to 1, which is what we're doing here. And for that reason, it's not increasing. Because the point is that the number is always going to be negative, and because this is a derivative, as long as it's negative, then that means this is not, it's going to be decreasing. And for that reason, you're just going to say this is less than or equal to 0, because it is for x is greater than or equal to 1, which you have there. So therefore, pass this test, and you can say series converges by alternating series test, or AST. Now, to be able to approximate what is the value if you took this to the infinite power, well, you can't really approximate this exactly. You could, but you'd have to basically be doing this for hours, and you'd never get an exact number. You can get a very close one, though. So, what we have to do for this is, actually, should I just do this on a separate video? what we're going to do is they're going to first off tell you. Okay, actually, now that I think about this, I think I'm going to do this in a separate video, because this is like delving into a completely different concept. So, yeah, that's the alternating series test.